The ability to easily program and visualize a PID loop can be a huge advantage for any engineer, because that way you can focus on your process and not how to apply it. Let me show you how easy it can be. As you can see, here's the 1516 controller. We also have an analog card with RTD and thermocouple inputs. I do have a resistor wired in and a thermocouple, and this is what we want to create the PID loop for. First step is, here in the hardware configuration section, I want to get focus to our analog card, right click and choose properties. Channel 0 is where the thermocouple is wired into, so I want to go down to the measurement section of this channel and change it from voltage to thermocouple. Okay, so the next step is programming. What I want to do is give focus to the main OB. As you can see, we have no code. Now what I want to do is add a new block, choose organizational block, cyclic interrupt, and the languages ladder, click OK. So now it's going to add this to our project. Once it has, now I would like to actually add a normally open contact, and let me choose a move operation. Let me move this over. Now we'll go to the bit logic and let's use a NOT. Let me get focus and let's add in a new branch. Let me go get another move real quick. Drag and drop it in. Okay, so now I want to create a reset. Let me drag another normally open contact and one more move. Alright, so now what I would like to do is actually use a conversion operation real quick. Let me choose a normalization. Drag it into this one. There we go. And then, last but not least, on the technology section, let me choose the PID compact. Let me drag and drop this in. Accept the default data block. And now our code is complete. The next step is tags. From the global library perspective, I can actually save function block groups, hardware configurations, and even tag databases. That way I can reuse the code over and over again, creating engineering efficiencies in my daily work. What I like to do is come over to our libraries, give focus to my tag database. Let me drag and drop it into the PLC tags. Now I actually want to give focus to all this code. Let me drag it up at the top here. So let's actually start programming. And let's tie the start to this normally open contact. Here's our set point on the back side of the move. Let's click on Control. Let's drag another one down. And let's do it a third time right here. And the reset happens to be this normally open contact. On the input, this needs to be a real, so let's do a 40.0. And this one's a 60.0. And on the reset, it's going to be a 0.0. Let's go down to the normalization. Let's grab the actual temp to the value input. It's an integer. And we have a min of 0 and a max of 10. And on the output, let's get the actual temp scale, because this is going to be a real. Let's grab the set point and drag it over to our PID compact. And let's get the actual temp to the input. And last but not least, the heater. Let's drag and drop it to the actual output. So now our tags are tied to our code. The next step is doing the actual configuration of the PID. In the upper right hand corner of this block, you see a little toolbox. Check on that. We get a dialog box of all the settings. The first step happens to be the actual controller type. Let's choose temperature in Celsius. And this is the version 2 PID compact and has a couple of differences, one of which is right here, the set mode 2. We can actually change it to automatic mode. That way, if you go from start to stop or power cycle it, it always goes to automatic mode and starts up immediately. The next thing I like to do is input-output parameters. On the output side, I want to change it to output PWM because we're going to do a pulse train output for this resistor, this heater. Now I want to go down to the process value scaling, and I want to change this high to 1000. And last but not least, on the output value, we also have something reaction to error for this new version 2 PID compact. We can do a substitute value or whatever the last known value is. That way if there's an error, he just maintains steady operation mode. Alright, so now we've done everything. Let's give focus to our PLC and actually click on the download arrow button. Now it's going to compile the fact that we've added in all these changes. Once it's done, we can actually click on load. Now it's going to load this down to our controller. And once he's complete, we can click on finished. The next step is visualization. What I would like to do is come over to a 12-inch comfort panel, and let's double click on the trend screen. Let's give complete focus to it. Click on fit to screen. Now at this point, I want to drag and drop this control icon called the trend view. This is an ActiveX control. Let me resize and refit him. Now let me actually give focus to him, right click and choose properties. Let me add the first variable in, and let's change an attribute. Let's change it to a blue line instead of black. Click OK. And let's go find one of our variables. Let's do the temp scale. This is a real. Let's add another one, and let's use the set point. There it is. Click OK. Now we'll come to the left value access, and let's do auto size. Same thing for right value access. Let's give focus to the comfort panel, and let's click on this start simulation. Now it's going to create a photorealistic view of it, and we'll actually get a connection to the actual controller over here. Connection has been established. Let's click on the trend screen. So now you can see some values being populated into the ActiveX control at this point. If I come over here and turn off the reset, you can see we're starting to pulse our actual output for this actual PID loop. And at this point, you can start to see the rise up to the current set point of 40. From the code perspective, if I turn it on, you see we hit a new set point and we'll continue to rise to meet the new set point. I was able to do all this visualization and control in just a matter of minutes. Now that's engineering efficiency.